Hello, everyone. My name is Levi Armstrong. I'm a senior research engineer at Southwest Research Institute. I'm going to be giving a brief introduction of the ROS Industrial Know-Their package. So we have found in a lot of industrial applications like painting, material removal, surface preparation, they follow a very similar sequence of steps. So they typically have data, whether that be scan data, mesh data, CAD data. You then do some type of feature processing on it. You then need to generate process paths to meet your requirements, and then you need to stitch those together using some type of sequence planner, and then you need to convert that into a robot trajectory. So for these different applications, we decided to create a framework that facilitated reusability of different components to allow you to switch out with different type of feature extractions or process planners to easily be able to test out, because every application is a little different. You might need to use a different type of tool for that different application. So the current capabilities, the framework is in place. It is plug-in based, so you can plug in different process planners and different robot trajectories. To test this, we have minimal implementations for each one of the core components. So for the feature extraction, we're using PCL cluster extraction. Our process planner uses polygon mesh to then generate a raster path. Because of that, the requirement on the polygon mesh, we decided to implement a mesher based on the advancing front algorithm based on several papers out there. We're currently working on getting that integrated into the PCL library. And then for the sequence planner, it uses more or less, for each one of the process paths, it looks at the start and end position of that process path and just uses the closest point to stitch each one of the process paths together. And for the trajectory planner, we're using Descartes. So here's an example of the advancing front mesher that was implemented as part of this effort. You have the Stanford bunny on the left. On the right shows the characteristics of this type of mesher. So it has a guidance field using the curvature information from the point cloud. So in areas of low curvature, you'll have larger triangles, and as you approach areas of high curvature, the triangles start to shrink to accurately represent that feature. So you end up with a mesh that has minimum number of triangles to meet a tolerance to represent that point cloud. This was very key to the process planner to generate nice raster path trajectories to follow the curvature. Here's an example of the process planner. So it's able to handle complex shapes. You can see on the left, and it shows on the right, shows how it handles holes in the data, generating the process paths. Here's an example of the closest point sequence planner. So each one of those paths, it then looks at each one of them and finds the closest point, and it stitches it together. So the blue arrow shows how it stitched it together to generate the overall trajectory to process that surface. The code can be found under the ROS Industrial organization on GitHub, on Know-Their. If you're interested in using the mesher, it's currently in an open pull request that's being integrated into PCL, and you can follow it there. And if you have any questions about either one of those, feel free to contact me.